Thank you for viewing this informational video about the obstruction identification surface functionality available within Esri's ArcGIS for Aviation. This video is intended to provide a functional overview of the tools within ArcGIS for Aviation, including examples using detailed step-by-step instructions. So to start out, I'm in ArcGIS desktop and I have my airport data, my airfield data. This includes a few different representations of the runway, including the center line, the threshold, the polygons, the paint markings, etc. Now, the first thing I want to do when I'm using ArcGIS for Aviation is ensure my extension is enabled. Now, depending on whether you're using ArcGIS for Aviation Airports or ArcGIS for Aviation Charting, you want to ensure that the associated extension is turned on in the Extensions tab. This will enable all of the tools on the Aviation Airports toolbar. Now, the first tool on that toolbar is the Obstruction Identification Surfaces tool. I've already loaded it and have it presented within the Table of Contents tabbed on the left-hand side. Now, for generating an obstruction identification surface, the process itself is really quite easy. In this case, I'm just going to select my runway center line. You'll see some of my attribution or my parameters have been filled out already. I'll go through them. The first is the specification of the surfaces I want to create. In this case, we have 5 different specifications, 3 here from the FAA in the US and 2 from ICAO specifications. In this case, I'm going to focus on ETOD, which is ICAO NX15. Now, the input runway is going to be the feature class that I want to use to generate the surface. Now, depending on your specification, this could be the runway centerline itself, it could be the thresholds, it could be several survey points along the centerline. You have the option to use any of those feature classes as input as long as they're in a projected coordinate system and as long as they have Z values enabled. In this case, I'm using the runway centerline feature class. And now I just need to specify my output. In this case, I have the option to choose polygon, multi-patch, or tin. In this case, it really depends on what your intended output of the geometry is. Polygon is great for two-dimensional visualization. So in the case of ETOD, defining area 2A, 2B, and 2C as collection areas. But if you're interested in doing vertical analysis or obstruction analysis, something like a multi-patch is probably better suited for that. In this case, I'm just going to choose polygon and then choose my output feature class, which is my obstruction identification surface. You'll see that's really it. There's not a lot of other parameters because ETOD is relatively simple in comparison. I do have the ability to add additional clearway links on the ends of the runway itself. These are predominantly used for planning purposes. If I want to extend where my primary surface begins and ends, in case of planning, I can do that with these 2 functions here. Now, all I do is click the generate button and you'll see my surfaces are created very, very quickly. If I go back to my table of contents and zoom out to that layer, you'll see there's my area 2A, 2B, and 2C, which could be defined as my primary approach and conical surfaces. Now, going back to my obstruction identification surface, I also have a tab called the Advanced tab. This is used for individually modifying each of the surface parameters themselves. So in this case, the primary surface, or if I want to change the approach surface. I can change the slope or the length, the divergence, the width, etc. All of these parameters I can modify individually to make changes based on whatever planning I'm trying to do. You'll also notice if I go back to runways, I can simply change my output to multi-patch, choose my output feature class, click the generate button again, and now I have my multi-patch features. So being able to generate the surfaces relatively easy and relatively quickly can be quite efficient for you. Now, the second thing I want to do, now that I have my surfaces, I want to perform a very basic and easy analysis based on the elevation and heights of all of the features around my airfield. Now, in this case, the next button on the Aviation Airports toolbar is the OIS Obstruction Analysis tool. This tool allows me to bring in my newly created OIS surface and then provide my obstruction data. Now, this is a point feature class that represents the obstructions on the airfield. I've added that to the data path in the analysis. You'll notice at the end I have this optional height field. Now what we found with obstruction surveys is they're usually collected in two different ways. Sometimes the Z value of the point will be at the base of the obstruction, and then the height of the obstruction will be stored as an attribute in a height field of some sort. The other way obstruction data is collected is the Z value of the obstruction itself will be the value of the elevation and the height of the obstruction. Either way, you have the option to perform the analyses both ways. In this case, I know my data was collected at the elevation of the obstruction, and then there's a height value, which is assigning the height of the obstruction beyond the elevation. Now I'm going to define a database just for my output, and I'm going to click OK. And once again, very, very quickly, even before I can say anything, the obstruction analysis has been finished. Now you'll notice in my table of contents, I now have this OIS obstructions feature class. I'm going to open it up, and you'll notice this is going to be the results of that analysis. It's got my information about my OIS data set, my obstruction data set, any surface type information, but then the important fields are really the Z and the delta Z field. Now the Z field is going to represent the elevation of the obstruction identification surface at that point. So this isn't the height of the obstruction, it's not the elevation of the obstruction, it's just looking at the obstruction identification surface at that point, and it gives us that elevation. So in this top case, this is going to be 15.36 meters, and this is going to be on the conical surface. Now the delta Z field, this is the really important information, because now the delta Z is the difference from that Z value to the height of the obstruction itself. What this represents is the difference or the penetration between the obstruction and the surface. So anything I have in delta Z that's a positive value indicates a penetration. Anything that's a negative value indicates there's no penetration. So to very quickly symbolize this, I'm going to symbolize by that delta Z field, change the quantity to 2, and I'll say I only want to see things above and below. So anything that's a negative value will be blue, anything that's a positive value, meaning a penetration, will be red. Now once I apply that, you can see I have quite a few penetrations around the airfield, but also other features that do not penetrate the airfield. So I'm going to zoom in to the end of the runway here and turn on the imagery, just so I get a better idea of what we're looking at. Now you'll see, I'll zoom in a little bit more, just off the end of the runway I have quite a few trees here, and just simply by using the identify tool I can now click on that information and I get not only the Z value, but also the delta Z value of that obstruction. So in this case, my approach surface is 20 meters above the ground, but these trees penetrate through that surface by 5.78 meters. So now I have that information to make any decisions necessary around the airfield. These trees may need to be cut down, or maybe this is a planning exercise, whatever that might be. Now, you'll notice also on the end of the runway, I have 2 trees that have obstruction information for them. And if I go a little bit south, you'll notice I have 2 trees that do not have obstruction information for them. This is okay. I'm now adding the terrain data. So this is just a DEM for this area. And I'm going to use the third tool on our Aviation Airports toolbar, which is the Evaluate Obstacle tool. Now by clicking on this tool, it brings up another dialog. And I can choose, once again, my OIS surface that I'm going to use, as well as the runway centerline that was used to generate the surfaces themselves. I can also define what units I want to report back the information. Now, if I go out into the data frame, you'll notice I kind of have a target cursor now. So what I want to do is head down to this tree and just click on it really quickly. Now you'll notice, I'll do this for the second tree as well, I get 2 separate parts of information now. Now it might be really hard to read up front, but what this is telling us is kind of an on-the-fly validation using the terrain data and the obstruction identification surface. Now I have a ground value of 1.75 meters here, an OIS value of 6.3 meters here, and a difference of just under about 4.5 meters here, negative. So what this is telling me on the fly is I have a difference between the elevation and the surface by about 4.5 meters. So this tree here, as long as it's smaller than 4.5 meters, albeit unlikely, is probably not penetrating through the surface. Now, really quickly, because that was hard to read, I do have some optional information or settings I can change about the output of this tool. And in this case, I'm just going to change it to white and click on that same information again to make it a little bit easier to read. You'll also notice in the terrain analysis, I'll get one more piece of information, and that's distance from the center line itself. So in San Diego, we actually have a displaced threshold all the way to the end of this runway here. The displaced threshold is almost 600 meters away. But at least this is good information if I'm trying to determine how far these obstructions are from the center line itself. So the last tool I'm going to show you, I'm just going to move to another MXD, is the terrain and obstacle profile. Now what this tool allows you to do is display your information. These are my obstruction identification surfaces and my terrain within a single data frame, and develop the vertical profile graph that needs to be shown on aerodrome obstacle charts. So you'll notice those are my obstruction surfaces that I created and the terrain. I'm going to click on the last tool, and once again it's just going to ask me for some upfront information. By default, looks like everything is correct, and I'm just going to click create. Now again, what this is doing is generating that graph behind the scenes and building it into a graphic to be displayed on our chart. Now at first, it might not be exactly what we're looking for, but that's okay. It looks pretty close. It's showing the approach surfaces and as well as any penetrating terrain around it. But by right-clicking and selecting properties, I can now go in and start to change some of my information. Some of the parameters I use to generate this. So for instance, I changed the scale, the vertical scale to 2. My horizontal scale I might change to 500. My vertical scale I might change to 10. Let's see what that looks like. There we go. So now if I kind of zoom in, I can take a better look and see what this chart looks like. And albeit it could probably use a little bit of cleanup, but very, very quickly and easily, I didn't have to manually draw anything. I didn't have to manually draw the terrain. The information is displayed for me effectively, where I can now take my cartographer and start to adjust this as any ways I see fit. Now, one last thing to show you is these graphs will dynamically update if I choose. So I'm going to go on my data frame and say I just want to focus on this approach surface here. So I'm bringing that in. I'm going to move it over just so we don't catch anything else. Now my terminal profile, or my approach profile that I've created, is no longer valid. But again, I can right-click on the properties of that and say refresh profile, click apply, and now my profile graph has been updated to the data frame. So regardless of what I've done in the past, it's very quick and easy to update my profile graph based on the information that's presented. So I want to thank you again for viewing this informational video, and if you have any further questions about Esri's ArcGIS for Aviation, please email us at aero@esri.com. That's AERO@ESRI.com. Thanks.